Hello guys, I am Deivandhiran. I am going to speak about the topic of uninformed search algorithm with my co-mates of Abdul, afzal, Abineswaran and Karthick. First we see about the searching algorithm in artificial intelligence. Artificial intelligence is the study of building agents that act rationally. Most of them, these agendas perform some kind of search algorithm in a background in order to achieve their tasks. A search problem consists of a state space set of all possible states where you can be, a start state, the state from where the search began, a goal state, a function that looks at the current state, return whether or not it is the goal state. The solution to a search problem in a sequence of action called the plan that transforms a start state to the goal state. This plan is achieved through search algorithm. Let's see about the type of searching algorithm. There are far too many powerful search algorithms out there to fit in a single article. Instead, this article will discuss 6 of the fundamental search algorithms divided into 2 categories as shown below. Search algorithm, it consists of 2 searches, uninformed search and informed search. The uninformed search has 3 categories: depth first search, breadth first search, uninformed cost search.
Here we see about uninformed search algorithm. The search algorithm in this section have no additional information on the goal node other than the one provided in the problem definition. The plans to reach the goal state from the start state differ only by the order and length of actions. It's also called blind search. This algorithm can only generate the successor and differentiate between the goal state and non-goal state. The following uninformed search algorithm are discussed in this section. First, depth first search. Second, breadth first search. Third, uninformed cost search. Here we see about depth first search. Depth first search is an algorithm for traversing or searching tree or graph data structure. The algorithm starts at the root node and explores as far as possible along each branching before backtracking. It uses last in first out strategy and hence it is implemented using a stack. Let's see this with an example. Here S is a starting node and G is a goal node. From S it goes to A and it does not goes to H before because here backtracking is not possible, and it goes to B and D. Here the branch gets over and it goes to E and C and finally G. Here we get the goal node. The final path of this tree is S, A and B, D, E, C and finally the goal node G.
Next we see about breadth first search. Breadth first search (BFS) is an algorithm for traversing or searching tree or graph in data structure. It starts at the tree root or some arbitrary node of a graph, sometimes referred to as a search key, and explore all the neighbor nodes at a present and depth period to moving on to the nodes at the next depth level. It is implemented using a queue. Let us take an example. Here G is a goal node and A is a source node. B and C are the child of A node. First, it will start from A node, it moves to A to B and B to C. After finishing the second level, it moves to the third, that is C to D. After reaching D, it moves to E and F and finally reaches the G, that is our goal node. The final path of this tree is A to B, B to C and C to D, D to E, E to F and F to G, that is our goal node.
The last topic is uniform cost search. Uniform cost search is different from BFS and DFS. Here, cost play the main role. In other words, traversing by a different edge may not have the same cost. The goal node is to find the path where the cumulative sum of cost is least. Let's see the example. Here's a tree. It starts from S node and ends at the G node, and we set the goal node as a G. In S node, it has two child, A and D. Here, A has the cost 1 and D has the cost 5. We should take the node which has the least cost. So we take the A node as a next one. In A node, it has only one child, B node. So we should take that only. After that, in B node, it has two child, C and G. And our goal node is G. So we are going to take the goal node as a last one, G. So the final path is S, A, B. Thank you guys.